see if she is.
Okay, yes, we'll start off with the homework and get that out of the way, and then we'll be looking at ways of determining functions type, whether they are linear, whether they are quadratic or exponential. And
Parabola.
yes, that's right.
Parabola.
That's right. The quadratic is the parabola. Yeah, we'll do it from the graph, from a table,
Mhm.
and from an equation. All right, let's get started. Let me share my screen. We'll get started, get the homework out of the way. But you got the other one right, so.
I couldn't do the one with the numbers and the letters of the alphabet.
Okay,
I don't know
now,
what to do.
do you see the homework on the screen?
Yeah.
Okay, now, Chastity, we're doing the first one. Latoya did this one and sent me the answer, so I sent her another one that you don't have, and we'll go through that one. F of 2 minus f of 1 and f of x is 6x plus 1. Okay, so f of 2 means wherever we have an x, we put a 2. And f of 1, where we have an x, we put a 1. So f of 2, which is 6x plus 1, we substitute a 2 for the x. That's 6 times 2 is 12 plus 1, that's 13. So f of 2 is 13. F of 1, we put a 1 where we have an x. So 6x becomes 6 times 1, then plus 1 right here. And 6 plus 1 is 7. Then we subtract them. The f of 2, which is 13, minus the f of 1, which is 7, and 7 from 13 is 6. And that's your answer. Chastity, are you following?
Yes, Ms. Barber.
Okay, so that's a substitution of the variable. Wherever we see the variable, the first one we put a 2 and the second we put a 1. And then once we find the value of those two functions, then we subtract them because it says evaluate f of 2 minus f of 1. Now, Latoya did this when she texted me the answer is correct. And I sent her another one. This one you don't have, Chastity. G of W, remember I said functions can be any variable. I mean, normally you see F, and it's just a shorthand way of writing things that you don't have to put it in actually words. You can just write it as an equation. So G of W is 4 over W plus 1. What is G of W plus 3? So wherever you see a W, you want to put a W plus 3. So 4 over W plus 1 becomes 4 over W plus 3 plus 1. Latoya, you following?
Yeah.
Chastity, you following?
Yes.
Okay, so where I have a W, I put W plus 3. Now we can combine our like terms, which are our constants. Then 3 plus 1 is 4. So the denominator is W plus 4. So our answer is 4 over W plus 4. Follow, Latoya?
Yeah.
So what were you doing? You sent me, I think you sent a W plus 4, but it was in the numerator, right?
Yeah.
Yeah, but the denominator has the W plus 1. The numerator just has the constant 4.
That thing bust my brain. I was like, I give up after 3 strikes. I'm
Really?
out. Yeah, because I didn't know what to do anymore.
Okay.
I was like, God.
Okay, try this one. What?
But I don't understand how you get the 4. W plus 4.
What's 3 plus 1?
Oh.
See, I can combine those constants, right? My denominator has W plus 3 plus 1. So I can combine the constants 3 and 1 and I get 4. Got it?
No.
All right, now let's try another one. Same one, G of W is 4 over W plus 1, right? All right, now I want you to find what is G of A minus 6. What is G of A minus 6? So let's just put that here. You tell me what I should write.
It's gonna be G.
Okay, I'm looking for G of A minus 6, right? So
Yeah,
what would that be equal to, Latoya?
it gotta be A G. Oh no. It's gonna be A minus 6.
No,
Don't you have to do parentheses first?
now this is the function right here. Using that same function.
Oh, it's a GW
Okay, so
minus
let me
6.
put it here. Okay, so it's the same function I had up here, except you're looking for G of A minus 6. So what would I have on the right side?
GW.
No, here's the function 4 divided by W plus 1. Where you have a W, you want to put A minus 6.
So it's gonna be GW equal 4 over A minus 6.
G of A minus 6 would be 4. Let me just copy this over. Put this here. Okay, take out that equal. Okay, so instead of 4 over W plus 1, what would I have, Latoya?
A minus 6.
Okay, so for the W right here, I put A minus 6. Okay, so that would be A minus 6 and plus 1. So what would that be equal to?
A minus 7.
Minus 6 and a plus 1 gives what?
A minus 5.
Minus 5. So what would be the answer?
4 over A minus 5.
That's right. You got it. So that would be 4 over A minus 5. So let's just put that here. So that would be 4. Combine the minus 6 plus 1 and you get a minus 5. So this will be minus 5. That's the answer. Wherever you have the variable, you put in the A minus 6 and your variable is a W. So wherever you have a W, you just put the A minus 6 and that's it right here, and combine it with the what was already there, plus 1. And you combine those constants. When you have different signs, you subtract. So 1 from 6 is 5, and you have more negative than positive. So A minus 5. You got it, right? So Latoya, it's not as bad as you thought, right? See how
No,
quickly
I still
see
don't really understand it.
no?
Because, no, not really. I'm trying to figure out. So the A, the G, and the A minus 6 is where we're gonna find, right?
Yeah, you're given a function of G of W is 4 over W plus 1. Now, whatever you're given to substitute, that will be substituted for the variable, which is W. So wherever you have a W, you'll put what is in this function notation, which is A minus 6. So you just take that A minus 6, put it in for the W, combine your like terms, in which are your constants, and you get 4 over A minus 5. Is it making sense?
I don't know. This one, I'm not getting it too well. So G A minus 6 equal 4 6 plus 1. So where you
Miss
supposed to
Barbara?
have a W?
Yes, yes, Chastity.
I'm sorry, where do I find this page, that page?
Oh, this you don't have.
Oh, okay, no wonder.
This is new because I gave you the one over on the left that we went through, right? And Latoya texted me the answer for this one, and I sent her another one. And this is the one I sent to her. And
Oh,
she
okay.
was having a problem solving it. So I say, well, let me go through this one to show her how she substitute for the variable.
Okay.
So this is new. This was an additional problem added to homework because Latoya sent me her answer to the first one, and I didn't want her to be bored, so I sent her another one to solve.
Okay, got it. Thank you.
All right. Are you following what I did here, Chastity? Substituting in for the variable?
It's still a little bit confusing, you know. I
Well,
guess me and Latoya are on the same boat.
okay. So when you substitute for the variable, remember the variable can be a number. It can be another variable and a number, or it could just be a variable. You know, if I said G of A, that means where we have a W, you'd put A. So it'd be 4 over A plus 1.
So suppose you have two variables
Two variables where?
in the A minus, say it's minus B. You could have that.
Right here?
Yeah, in the bracket parentheses.
Well, yes, you could have whatever. And whatever it is, you put it for the W. Or for, wait, okay, let's do this. Okay, you say suppose if you had two. Okay, let's take that same function. Okay, let's just take this one. Now I'll copy this and I'll change this. Okay, and I put here, okay. Now, suppose I had you want like two functions. Suppose I had G of X plus Y. All right. So what would G of X plus Y be? What would be the answer? If G of W is 4 over W plus 1, what is G of X plus Y?
So it's gonna be 4 over X plus Y.
And what else is on that in that denominator? You got part of it right, Latoya. What else is in that denominator?
This thing is gonna be crazy.
No, see, you got 4 plus 1. Let's just copy that. So G of X plus Y would be equal to 4. Now so what's the W? What would I put for W?
X plus Y.
That's right, X plus Y. And then I'll have just plus 1, right?
Oh, I left out the one. That's what
You
I'm trying
left,
to find
yeah,
out
that's
something
right.
else
You
is
left out the
missing.
1. Yeah, you left out the 1. You have to keep what's there, but substitute in for the variable. So that would be the answer for that one. You got it?
Oh,
So it could
yeah,
be,
because I'm putting that in my back pocket because they changing math too much now for me.
yeah. So if you had two variables, you just substitute those two variables for that variable that's in the function notation. So wherever you see a W, you put the X plus Y. Just like if this was G, okay. What would G of 3 be? Let me put this here. Okay. What is, and this is meta math. What is G of 3, Chastity? Chastity, what is G of 3? Mental math. Got the same equation, the same function. And I want to know what is G of 3. Chastity, you have the answer? Yes. Chastity? Latoya, what's G of 3?
3G.
What?
Oh, no. 4 over 3 plus 1.
Which is what?
4.
What's the final answer?
4 over 4
Which is equal
plus
to?
1.
That's it, 1. Just equal to
But
plus
you
1 or
forgetting the
1.
1.
Yeah,
So
and yeah, you put the 3 in. 3 plus 1 is 4, and 4 over 4 is 1. So G of 3. What is G of 3? G of 3, let's just copy this over. And here you're coming out with just a number. Because for the W, you're putting a 3. So you put the 3, substitute the 3 for the W. And that's equal to what? 4 over 4, and 4 over 4 is equal to 1. Making sense now, Latoya?
yeah, a little bit. Not
Okay,
much.
so 4 over 4. This is a 4. And 4 over 4 is equal to 1. That's the answer.
No, where's the plus 1 at the bottom?
What do you mean the plus 1?
Oh, yeah, I remember
got
it
it?
now. Yeah.
See, you just got 4 over 4.
So you have to reduce it too?
Well, usually you simplify. And if you given like multiple choice, they're gonna have the simplified form of the answer. So you wouldn't leave it 4 over 4. You just put that G over W equals 1.
No.
See, it's the
God help us.
substitution of the variable. The only difference, see, you've done this before, but you didn't do it with a function notation. In other words, let me just put what you've done before. Okay. See, the function is really the output. That's like y. Like if I gave you y equal 2x plus 3y plus 7. And I ask you, what is the value of this equation? And I'll give you some values for x and y. Okay. What is the value of this equation when x equal 2 and y equal 3? What would you tell me, Latoya?
They're gonna be y equal 2 and 2 in the parentheses.
Okay. So let's see, let me just bring this up so I can just keep this on the same page. Okay, so this y equal, let's just copy this and you tell me what to put. So it would be, you said parentheses, and what would I put for the x?
2.
Okay, so that's right, x is 2. And what is the y?
Y is 3.
Okay, y is 3. Okay, now what is that equal to?
4 plus 9 plus 7
Okay, equal 4 plus 9 plus 7. And what's that equal
equal
to?
20.
Okay, 13 plus 7 is 20. Now, what we've done before is really the same thing. The only difference is we said function of something. All right. And whatever is in the, we said, what is the function notation? What is function of the value? So what I'm substituting is like within the function expression. Whereas here it's just y, but a function of something is really equivalent to y. This is the output. On the right side is the input. X, Y constants, all this is input. And the Y is the output. It's dependent upon what's on the right. Just like the G of W is our Y and it's equivalent to what is on the right. So it's no different. You see how quickly you did that one? You're doing the
'Cause I'm
same
used to this
thing.
one.
Yeah, you're used to this one, but this is just a function notation, just a shorthand way of writing it as a function notation. But the substitution is the same progress. It's the same process, except what you substitute, like I said, X is 2 and Y is 3, except what you substitute is within the function notation. Like what is G of 3? I substitute 3 for the variable. If it was 3 plus A, I substitute 3 plus A for the variable. Got it?
Yeah.
Yeah, it's just a different way of notation. Okay. Special way of notation where the Y is the dependent variable, dependent upon what the variables on the right. Same thing here, G of W, independent variable. I mean, dependent variable, dependent upon what's on the right.
The
Dependent.
last one where you do, don't it can do for something else? It's a linear or
One.
this one, the one with the numbers. Don't you can do it in another mathematical form? It's like an algebra.
What other form?
Like you could do it a different way in math. This is not a part of algebra too.
All this is algebra.
Oh, yeah, that's what I was trying to think.
All of this is algebra. Whenever you're dealing with variables related to numbers, that's algebra.
Oh,
Okay. If you're just dealing with numbers, it's it's arithmetic. But whenever you have variables related to numbers, you're dealing with algebra. So functions really comes under algebra. Okay, sometimes
okay.
it's taught under algebra, not separate. Okay.
Mm.
All right. So this is function notation. Normally f of x could be a of x, could be z of x, g of x, h of x. Okay, where the number in parentheses is the variable. And that's the number you'll be, when you're given a number instead of the variable, you're substituting for the variable that number or that expression. Doesn't have to be a number. It could be a variable, could be a variable along with the number, could be more than one variable. So in some of these, you get just a number. All right, like here we got G of W is 1, right? Some of them you get a variable like G of W 4 over W plus 1, where we had further up. We just got a variable, a number on top of a variable, plus a number. Now, as we do more of these, it'll start making more sense, all right? Okay, now there are actually several kinds of functions, but we're only looking at linear, quadratic, and exponential.
Oh,
Linear functions, polynomial with 1 degree, all right?
I thought I was running from a quadratic. Oh,
Quadratic
oh
functions
God.
have what? Second degree. In other words, whenever you see a square on something, you're talking quadratics, right? Exponential, the function is represented by the power as the variable. Okay, so linear, they're like, this is like our ax plus b, our slope intercept, where we have y equal mx plus b. That's linear. Polynomial functions, second degree, you always have a square. If you don't see a square there, then you know it's not quadratic. The general form, ax squared plus bx plus c. A, B, C are constants, all right? And then of course the x is the variable. Now this is f of x. This is same as saying y equal ax squared plus bx plus c. Same thing, okay? And of course, we looked before at a quadratic formula where we can solve for the x using the quadratic formula. Now, exponential, the function is a to the power of x, where the variable is an exponent. Now, we can identify these functions. We can use a table, we can use an equation, we can use a graph. Now, I gave you some mnemonics here. H0y. When your slope is 0, you have a horizontal line. When it's undefined, you have a vertical line. Now, let me just show you what I mean by this. Let me go to a new share and go to the whiteboard. Now, okay, let's draw a line here and a line here. This is X and this is Y. Now, if I have a line, just a straight line here, okay, and I'll just say X here is 4. Now, X has the same value of 4, right? So how do you find slope? Slope is the difference in Y over difference in X. So the Y is changing, but the X is staying the same, right? So the difference in Y over the difference in X. So if the X value is staying the same, that means I'm dividing by 0. That's undefined, okay? That's why we said V, U, X. That's how you can remember it. The vertical line, right here, vertical, where the X value is the same, that's the denominator, then the slope is undefined, because when you divide by 0, you get undefined, right? You follow? Just
Yeah.
slope, rise over run, or difference in Y over difference in X. So slope of the line, okay, that's equal difference, okay, in Y, okay, difference in Y, and that's divided by the difference in X. Difference in Y divided by the difference in X. So you see your vertical, which is here, that X stays the same, difference. So there's no difference, because if that's a 4, 4 minus 4 is 0. And divided by 0 gives you an undefined. All right. What if it's a horizontal line? Okay, let's draw a horizontal line. And we'll say this is a 4. All right. So what is staying the same on this one, Latoya, for the horizontal? What is staying the same?
It's on the X line.
This is the Y line, this the X line. So what is staying the same? The Y line, right?
Yeah, the Y line.
That's staying the same. That's why we said H 0, the slope, and Y. So the horizontal line, you notice that right here, the Y is staying the same. So if you say difference in Y, that would be a 0, because 4 minus 4 is 0. And 0 divided by a number is 0. So these are some little mnemonics to help you know whether a line is undefined or 0. So vertical lines, undefined. Horizontal line, slope 0. So H0Y, sometimes it's called Hoy, and Vux, VUX, U for undefined, vertical, X. All right. Horizontal, this is 0 for Y. So right here, the Y value is staying the same. So numerator 0, difference over whatever that number is. And that will help you know when you're given these lines what the actual slope of it is. And this is most times give you in terms of a multiple choice. Like they'll give you a line like this and say A, let's just say A equal, not A, I'm sorry. Let's say X equal 4. That's a linear equation. X is 4. So when X is 4, you've got a vertical line, right? Where X is 4, okay? And X is 4. Whereas the horizontal, you have Y equal 4. That's a linear equation. Y is 4. Y is equal to 4 represents a horizontal line. X is equal to 4 represents a vertical line. Okay, so just keep in mind Hoy and Vux. V for vertical, H for horizontal, Z for slope, Y for the line, V for vertical, undefined, X for the line. Okay, now let's go back to all right. Now here are some samples of the equations. When you see these equations, these are linear. Y equal 5. All right. Y is equal to 5. That means we on that Y line, and the Y line is a 5. The X values are changing. So we have 5 minus 5 is 0. That's a 0 slope. Okay. H or Y slope 0. The vertical, we could have a X equal 5, and that would be, see, vertical X equal A, where A is a constant. So X is 5, that would be the vertical line, undefined. So all of these are examples of linear equations. 2x plus 3y is 6. Notice you don't see any powers here other than 1, because you don't have to put x to the 1. That's the default. All right. But if you have an x square, your highest power is 2. That's a quadratic. So you can identify these equations, these type of functions from the equation. All of these represent quadratic. 2x squared, x squared, x squared plus 4y is 7. Those are all examples of quadratics. All right. If you have a power greater than that, then it can't be quadratic. All right. Now for exponential, the variable is in the exponent. So they are in this format. Y is 3 raised to the x power. Y is 5 raised to the 2x power. 4 to the x power plus y is 13. Those are all examples of exponential. Whenever the variable is a power or exponent, we can call it, that's an exponential equation or an exponential function. Now we can also identify it from a graph by the way it's shaped. And you familiar with, I think, most of these straight lines. That's linear, right? And it can be increasing, or I could come this way, sloping downward, decreasing, still linear, right? But now if it's a quadratic, and Latoya, what do you call this one? Latoya, what do you call this? The U shape? Parabola. That's a parabola shape. And it could be this way, increasing, or it could be upside down, sort of an upside down U. And that's also quadratic. So it makes a U or this shape, which looks more like an upside down U. Now, when you get to exponential, notice they look like this. It seems to be steady, then it rapidly goes up. And that increase, we call that exponential growth. Now, when it slopes downward, decreasing, where it's the same, and then it falls quickly in this direction, we call that decay. So for exponential, you have increasing, decreasing, increase called growth, decrease called decay. Now, so we looked at the equations, we looked at the graph, and this is the way you determine whether you have exponential, whether you have quadratic, or whether you have linear. Now, you can also identify it from a table. And how do you do that? You look at your values, and this only works if your X value is changing by the same amount. And here they're all changing by 1. So if the X value is changing by the same amount, which all of ours will be, then you take the Y values, get the difference, and if they are all the same, then that function is linear. That's our first difference. Now, a -4 minus a -1 is a -1 plus 4 or 3. A -1 minus a -2 is a 2 plus 1. Or if you want to do it backwards, 8 minus 5 is 3. 5 minus 2 is 3. 2 minus a -1, which is 2 plus 1 is 3. And -1 minus a -4 is -1 plus 4 is 3. So all these values are the same, all these differences. That means this table represents a linear function. Any questions on linear? Latoya, you're on mute.
Yeah, you gotta send it to me because I don't remember this one.
Okay. Oh yeah, I'll be sending you this whole session.
Yeah, I gotta read it over.
Yeah. So you get that this is using the table to determine whether it's a linear function, quadratic, or exponential. I'm going through these and then you're gonna practice them.
Yeah, I need to.
Okay, then I have some for practice. Okay, so you get the difference in just the Y values. If they are the same, then you have a linear function. All right, they all have to be the same value.
They have to be the same value for linear.
Yes, the same value, difference in the Y values. All the X values, difference has to be the same. Now, all of these are different by 1, right? -2 plus 1, that's a 1, minus 1, 0, that's a 1, 0 to 1 is a 1, and 1 to 2 is a 1. So all your X values have to vary by the same amount. And all of ours we'll only use X values that vary by the same amount. So this rule holds. When you get the difference in Y and they're the same, then it's a linear. Now let's go to number 2. Now number 2, if the second difference, and that's like the difference of a difference, are the same, then it's quadratic. So when we get the difference between these values, we see they're all different, right? So we know it can't be linear because all these differences are different. In order, all these differences, none of them are the same. All right. And that's 55 minus 36. You get 19, 36 minus 21, 15, 21 minus 10, 11, 10 minus 3, 7, 3 minus 0, 3, 0 minus 1, minus 1. Now, these are all different. Now, if you take these values and get the difference, then if they're the same, then it's quadratic. So 19 minus 15 is 4. 15 minus 11 is 4. 11 minus 7 is 4. 7 minus 3 is 4. 3 minus a minus 1, which is 3 plus 1, is 4. So since the second differences are all the same, this is a quadratic. Any questions on that one? Questions? So once you get your first difference and they're not the same, then you go to your second difference. And if they're the same, then it's a quadratic. Okay, so first difference the same, linear. Second difference the same, quadratic. Now, when we go to the exponential, the differences are not the same, but the ratios are the same. So if we take, so you could really say 4 over 12 is 1/3, or you could say 12 over 4 is 3, 36 over 12 is 3, 108 over 36 is 3, and 324 over 108 is 3. But like I say, you could also say 4 over 12 is 1/3, 12 over 36 is 1/3, 36 over 108 is 1/3, and 108 over 324 is 1/3. In all cases, the ratio of your Y values are the same. That means that this table represents an exponential function. Any questions? Okay, let's go to our next. Okay. All right. Now, based on what we just went through, tell me, look at this first table, take your differences, tell me if number 1 is linear, quadratic, or exponential. I give you a few minutes to do that one. Answer number one. Latoya, Chastity, any answer on number one? Is it linear, quadratic, or exponential?
Which one is this? A?
Number
It's
one.
linear. Linear.
Why is it linear?
I don't know.
You guessing? Did you get your difference in your Y values?
No.
What's
It's
14 minus?
quadratic.
You say quadratic?
Let me see. No, it's exponential, whatever the word is. It's exponential.
Okay. What's 14 minus 10, Latoya?
4.
Okay. All right. Let me put this. Okay. So let's do this. Okay. So, okay. So you say 14 minus 10, and that's equal to 4, right?
Yeah.
All right. Now you've got, let's see. Let me go here. 10 minus 6 is what?
4.
10 minus 6 equal 4. Okay, what's 6 minus 2?
4.
All right. So far, they are all coming out the same, right? That's equal 4. Okay. What's 2 minus a minus 2?
0.
No. 2 minus a minus 2.
Or 4.
That's right. That's 4 because that's
Sorry.
like 2 plus 2, right? So
Mhm.
that's 4. And what's minus 2 minus a minus 6?
4. Minus
Right.
4.
That no, not minus 4. Minus a minus 6. Minus is going to give you a plus. So that's
Oh.
like 2 plus 6. Minus 2 plus 6 equal 4. Right? And then the last one, minus 6. This is minus 6 minus a minus 10. A minus 10 is a plus 10. A plus 10 and a minus 6 also give you 4. So that means this equation is what kind of equation?
Linear.
That's right. It's linear because differences are all the same. So that means number one is linear. All right. You took the difference of your Y values, and in all cases, you got a 4. Okay. Every case, the difference was a 4. So where the differences are the same, the first difference is the same, then you get a linear type function. Okay.
Okay.
Questions? Okay, try number 2. Let me just bring this one over on the other side so you look at the whole table. Okay, number 2. Try that one. Tell me if it's linear, quadratic, or exponential. Number 2. Now, if you do the first couple and you see they come out different, then you know it can't be linear, right?
Yeah. It's exponential, whatever that word is.
That's right. You're right, Latoya. It is exponential. And why? Why do you say exponential? That is correct. But why do you say that?
They don't come out the same.
What do you mean they don't come out the
The
same?
answers don't come out the same.
What doesn't come out the same?
When you subtract, it doesn't come out.
In other words, your differences are not the same. So you
Yeah,
know,
that's what I mean. I said when
right.
you subtract.
Yeah, yeah. When you subtract, you don't get the same numbers because if you say 32 minus 16 is 16, 16 minus 8 is 8, 8 minus 4 is 4. So you're not getting the same difference, right? And if you took those differences and got differences, you're not going to get the same. But you notice something here. Each one of these numbers is 2 times the value of the number that precedes it. So that means the ratios are the same, right? So if the ratios are the same, then it has to be exponential. Ratios are the same. So if the ratios are the same, then it has to be exponential. It can only be exponential. Okay. And 32 over 16 is 2. 16 over 8 is
Sorry,
2.
but I'm sleeping.
8 over 4 is 2, right? 4 over 2 is 2. 2 over 1 is 2. 1 over 1/2, which is 1 over 2 times 2 over 1, which is 2. So the ratios are the same. And they are 2. So the ratios are 2, so that means it's exponential. Because remember we said that y have common ratios, and that's an exponential. All right, do number 3. Tell me what that one is. 1 was linear, 2 was exponential. Now do number 3. Tell me what you get. Tell me what you get and tell me which function it is and why it is that function. Get your differences. If after you do 2, they're not the same, then keep going and then get your second difference. Okay, we're doing number 3. The two of you have an answer? Answer for number 3.
Yeah, Miss Barbara.
What did you
You
get?
can hear me?
Yes.
It's only doing number 3.
Number 3, yes.
It's what do you call it? was doing number 4. I'm doing the wrong one.
You're doing number 3 right over here.
Yeah, I was
My-
because it switched over.
Yeah,
thought I was
21,
doing the wrong
12,
one.
21, 12, 5, 0, minus 3, 4, minus 3.
Let me see. 3 minus 3, 0.
21 minus 12. What's 21 minus 12?
10.
No,
11.
21 minus 12?
Oh, 9. Sorry.
9.
I'm sorry.
Latoya, I
Oh,
was
God.
wondering what kind of math you do. 12
Oh, God.
minus 5. Well, it is late. You've been working all day, so I give you an out.
12 minus 5, 7.
Yep. Okay. And 5 minus 0.
0.
What?
5 minus 0, 5.
Right. Equal 5. Okay. And then 0 minus a minus
Minus
3.
3.
What's that equal?
0. 3.
That's
The
right.
sign is the
That's
same.
right. 3 minus 3 give you plus 3. Okay. So 3 minus a minus 4. Minus a minus 4. What is that equal to?
It's 10. No, it's 9. I
No.
was saying,
3 minus a minus 4 is 3
oh, it
plus
looks
4.
like a 5. It's 7. Sorry.
No, Latoya. 3 minus a minus 4. That's like
Oh, it's
3
a minus
plus.
1. It's 7.
No. Minus 4 is a plus 4. And a plus 4
It's a minus 1.
no, I'm sorry. This is a minus 3. I knew it was something wrong here. This is
Yeah,
a
because I was
minus.
saying it's a minus 1.
Yeah,
And you
it's a
said no,
minus
so I'm
3
confused.
minus a minus 4. And a minus minus is a plus. So what is that, Latoya?
A minus 1.
A plus 4 and a minus 3 is a
Minus 7.
plus 1.
Oh, you keep the sign of the bigger number. Oh,
Yeah, well, minus is plus. So a plus 4 and a minus 3 give you a plus 1. All right. Then a minus 4 minus a minus 3 is what? Okay. Minus 4 minus a minus 3. What is that equal to? Minus 4 minus a minus 3, Latoya.
a minus 1 this time.
That's right. That's right. Yeah, minus 3 give you a plus 3 and a plus 3 and a plus 3 and a minus 4 gives you a minus 1. Now you can see they're not the same, so it cannot be linear. Okay, let's go for our second difference. Okay, now 9, this is our second difference. 9 minus 7 equal what? Latoya, what's 9 minus 7? Nine minus 7.
It's 2.
That's right. That's 2. Okay. Now what's 7 minus 5? Let's take our next difference. 7 minus 5. And what's that equal to?
2.
2. Okay. 5 minus 3. Okay. 5 minus 3. And that's equal to what? 2.
2,
right? 3 minus 1. Okay, 3
2,
minus 1 equal 2. Okay, what's 1 minus minus 1? 1 minus a minus 1. What's that equal to, Latoya?
positive 2.
That's right, 2. So we see our second difference is 2. So that means what is number 3? What kind of equation? What kind of function? When the second differences are the same.
So it's linear.
No, the first difference has to be the same for it to be linear, but we can see the first differences are all different numbers, 9, 7, 5, 3, 1, minus 1. So it can't be linear because all these differences must be equal, but they're not the same. But when we got the difference of these values, we got the same number. So what kind of equation, Latoya?
Exponential.
What? Exponential has to be a ratio. When the second difference is the same, it's quadratic. Okay, when the second difference are the same, it's quadratic. So this has to be a quadratic function represented by this table. Okay. This is, then the ratios are not the same. 21 over 12 is not the same as 12 over 5. See, remember, for a ratio, then when you put one number over the other, you should get the same as if you took the second number and put it over the third number, but you don't get the same. It's not the same ratio, so it can't be exponential. Can't be linear because your first differences are not the same. They have to, the Y value differences have to be the same for it to be linear. When you find they're not the same, then you take the difference of these differences. So it's like the difference of the difference, or you can call it the second difference. That second difference is the same, so it is quadratic. Got it? Questions?
So when you do the X, you do the X first and you minus it from
No,
the
you
Y.
don't. No, you don't do X. X you don't do anything with. For this to work, all your X differences have to be the same. But what I'm giving you is all my X differences are the same. So you don't look at the X, you look at the Y differences. Difference in your Y values. If they are all the same, it's linear. Here, they're different. The first difference is 9, next difference is 7, next one 5, etc. So we see they're not the same, so it can't be linear. Then we take the difference of these values, 9 minus 7, 7 minus 5, 5 minus 3, 3 minus 1, 1 minus a minus 1. And in all cases, we get 2. So that second difference is the same in all cases. That means it's quadratic. Questions? Latoya, any question?
So you do the Y value first or you do the X value first?
No, you don't do X at all. When you're looking at the tables, you don't do X values at all. All your X values are showing the same difference. So you don't worry about the X's. This only apply to Y value differences. Okay, so you look at the Y values in the table. If all your Y value differences are the same, then it's linear. If they're not, you can go to your second difference. That is the values you got from your first difference. Take those differences. If they are the same, then it's quadratic. And that's what we did. We took these differences over here and got the difference. The 9 minus the 7, 7 minus the 5, 5 minus the 3, 3 minus the 1, and 1 minus the minus 1. In all cases, we got differences of 2. So since those second differences are the same, that means this table applies to a quadratic function. Follow? Questions, Latoya? Chastity,
The
questions?
part I'm not understanding is, I see where you get the 21 minus 12 equal 9.
Right?
Well, where you get the 12 minus 5?
Oh, from the table. 21 minus 12, 9. Take the next one, 12 minus what follows it is 5. That's 7, right? Then take the 5 minus the 0, and that's 5. Then take the 0 minus a minus 3, which is 0 plus 3. Okay. And then a minus 3 minus a minus 4, which is minus 3 plus 4, and that gives you 1. And then a minus 4 minus a minus 3, which is minus 4 plus 3, gives you minus 1. And then I take these differences and I go from 1 to 2. 9 minus 7. 7 minus 5. 5 minus 3. 3 minus 1. And 1 minus a minus 1. And in all cases, I get a 2. So that second difference, the second differences are all the same. That makes it quadratic. Did I answer your question, Latoya?
Yeah, you did. Because I was wondering where you get it from.
Yeah, I got it from the table.
I
This is-
understand the 21 minus 12, but
Yeah.
then I was lost. I didn't know what
Okay,
else,
there's the
to do.
12.
That's why.
Then take the second entry in the
So
table.
you don't touch your X, right?
No, don't even touch the X.
Okay.
All Y
Okay.
differences. 21 minus 12, 12 minus 5, 5 minus 0. Just go right down the table. 0 minus a minus 3, minus 3 minus a minus 4, minus 4 minus a minus 3. Okay?
Mm.
Only the Y values are you getting differences for. And we can see, well, once you see these differences are not the same, then you know it can't be linear. Once you got a 9, you got a 9 here. If you don't get a 9 next, then you could just really stop. But you don't want to stop because you know you will have to get your second differences. So you keep going so you can do your second difference. Got it? So Latoya, do number 4. Tell me what kind of function is number 4.
I'm in the list, so you're gonna be.
Only look at your Y values.
I'm getting 26. 16 minus 13, 3.
Minus 16 minus a minus 13. Okay.
Is a minus 3.
It's a minus
yeah.
what? Minus 16 minus.
3.
Okay, let me put this here.
Thank you.
Minus 13. What's that equal to, Latoya?
Minus 3.
That's right, minus 3. Very good. Okay. Now,
Yeah.
what would be the next one? What would be the next one I would put?
I'm trying to figure this out faster now. 10 minus 7.
No. The next one is a
A
minus
minus
13.
10 minus 7.
No,
Oh, no, 13 minus 10.
minus
A
13.
minus 13 minus 10.
Okay, minus 13 minus a minus 10.
10.
What's that equal to?
Mm. 3
Plus or minus?
plus 3.
A minus 10, a minus 10 is a plus 10. So a minus 13 and a plus 10 give you what?
A minus 3.
That's it, minus 3. What's the next one?
The next one is a minus 10 minus minus 7.
Minus 10 minus a minus
Minus
7.
7.
And what's that equal to?
A minus 3.
That's it. Minus 10 plus 7 gives you minus 3. Okay. And what's the next one?
A minus 7 minus a minus 4.
Minus 7 minus a minus 4. And that gives you what?
A minus 3.
That's it. Minus 7 plus 4 gives you a minus 3. All right. And what's the next one?
The next one is a minus 4.
Minus 4 minus what?
A minus 1.
That's right. Minus 1. And what does that give you?
A minus 3.
That's right. Minus 4 plus 1 gives you a minus 3. All right. And the last one. The last one. You gave me minus 4 minus a minus 1. What's the last one, Latoya?
So 2. Minus 1.
Minus 1 minus 2. And that gives you what? Minus.
A minus 1.
No, minus 1
Minus
minus.
3.
That's it. Now, your first differences are all the same. So that makes this what kind of a function?
Linear.
That's it. Very good.
That's the only one I get first. I don't know.
Okay, that's a linear. Very good. Okay, so first difference all came out the same. So that's
I know.
that
I'm just
table
busy.
represents a
Sometimes.
linear function.
They don't remember me. You know? Oh God, he's scary. What's up? What's up, Noah? What's up, sweetie?
Latoya, you've got to go to mute. You got a lot of noise going on. You're in the cab, right? Latoya? Are you in the elevator? Latoya?
Yeah.
You were on the elevator? In the
Yeah.
cab? Oh, okay. All right. So that's the way you can determine the function from a table. You don't use the X values, you just take difference in the Y values. They're the
After all
same.
these years, I finally get this one because I always wonder where they get it from. And
Okay.
I couldn't do it at all.
Well, that's why with the tables, you get your differences. If they're all the same, you have linear. If they're different, then you go to your second difference. And if those second differences are the same, like in number 3, then it's quadratic. But sometimes, like with the exponential, you can look at it and see that the ratios are the same because you see the numbers differ by the same, not amount, but they differ by the same factor. And that means that it's exponential. Now we want to look at some, I think the next thing is some word problems. Okay. All right. Now let's look at some word problems. Chastity, read number 1, example 1.
To manufacture a certain product, a company spends X dollars on raw materials and Y dollars on the labor. If the production cost is described by the function f x x y equal 36,000, I'm sorry, plus 40 x plus 30 y plus xy slash 100. Calculate cost of production when the firm spends $10,000 on raw materials and $1,000 on labor, respectively.
Okay, so X, let's just put what they said here. X dollars is equal to raw materials. Okay, so X dollars is raw materials. Let's just put that here, and we don't need to underline that. And Y dollars is labor. So let's just put that there. Y dollars equal labor. Okay. So that's raw materials, labor, we'll just put cost here. Labor cost, X dollars is raw materials cost. Now, the production cost is actually given to you. The production cost use a function that includes raw materials and labor. So this is the production cost. Function of X and Y is equal to this. Okay, so this is our function. The function of the X dollars, that's the raw material cost, and the Y dollar labor cost is equal to a formula that says 36,000 plus 40 times X plus 30 times Y plus XY over 100. So that 10,000 on raw materials means that the 10,000 is for raw materials and the 1,000 for the labor respectively. Okay, so for the X, and notice it said X on raw materials, so 10,000 on raw materials, and that, let me just put that here. So that would be equal to X, and 1,000 on labor, and I'll just put that there, and that's equal to Y. All right, so what you need to do is substitute in this equation for X, 10,000, for Y, 1,000. Same thing here, X times Y, which would be 10,000 times 1,000 divided by 100, and calculate it, and that would give you what they said is the production cost. Everyone, you following me now? Yes. Any questions on what I just said? So the function includes both raw material cost X and labor cost Y. And the formula was given as the 36,000 plus 40 times X, where X is the raw materials cost, plus 30 times Y, where Y is the labor cost, plus XY, which would be raw materials cost times labor cost. That's 10,000 times 1,000. And then of course, all that product divided by 100. So let's just substitute in the values that's given in the equation. And I mean, the values that are given here in the problem. So F of X and Y would be X raw material, 10,000, Y labor, 1,000, 36,000, that's in the formula, plus 40 times X, but X is what? X is 10,000. So 40 times 10,000 plus 30 Y, Y is 1,000, 30 times 1,000 plus XY, which would be 10,000 times 1,000, and all of that divided by 100. Okay, now it's just a matter of multiplying everything out. Let's see. So 36,000, 40 times 10,000 is 400,000. 30 times 1,000 is 30,000. Okay. 10,000 times 1,000 divided by 100 is 100,000. So we add those up, 36,000 plus 400,000 plus 30,000 plus 100,000 gives you a total of 566,000. That would be what they call the production cost. So the 566,000 represents production cost. And production cost is given by this function right here. Any questions on number 1? That function had 2 variables, X and Y, but we were given the values of X and Y. 10,000 for X and 1,000 for Y. So in the formula, we could substitute those values for X and Y and then calculate what the production cost would be. Any questions on number 1? Questions? Latoya?
Yeah,
Okay. Were you following on example 1?
no, not really.
Chastity, were you following on example 1?
Because it's in a word problem, right?
Yeah, this is a word problem. Yeah.
Oh,
Okay,
God.
this one, you
This is a lot.
you're manufacturing a product and you spend X dollars on raw materials and Y dollars on labor. And they give you a formula for production costs, but the function includes both raw materials and labor. That's why you have X and Y. X for the raw materials, Y for the labor. And this was given 36,000 plus 40 times the raw material cost plus 30 times the labor cost plus the raw material cost times the labor cost divided by 100. So we put this equation right here. That's the one they gave us, right? The 10,000, because they told you the X dollars was on raw materials, the Y dollars on the labor, all right? But the 10,000 is spent on the raw materials and the 1,000 is spent on labor. Okay. So we can, this was given in the problem. So now in our function, we have the 36,000 a constant, 40 times X. X was the 10,000. So we substitute for X 10,000, which is what we have right here. 30 times Y was the labor cost, which is 1,000. That's why we have 30 times 1,000. Now, X times Y divided by 100 would be the 1,000 for the X, I mean the 10,000 for the X times 1,000 divided by 100. Now, when we simplify all of this, we get 36,000, 40 times 10,000 is 400,000, 30 times 1,000 is 30,000. 10,000 times 1,000 divided by 100 gives you 100,000. Okay, and then we just add all of this together. 400,000 and 100,000 is 500,000. 30,000 and 36,000 is 66,000. So your total production cost is 566,000. Latoya, did you follow the substitution?
Where you get the $10,000 from?
Oh, that was given in the problem. I just put it here. I just put it what it is right here, but it was given in the problem. It said when the firm spends 10,000 on raw materials and 1,000 on labor. They gave you that in the problem. I just defined it here. Okay.
I didn't see it. That's why I don't understand this at all.
No, it said when the firm spends 10,000, this is the way it was given in the problem. I just simplified it. 10,000 on raw materials and 1,000 on labor. Okay, that was given in the problem. Calculate cost of production when the firm spends 10,000 on raw materials and 1,000 on labor. That's they gave you all of this in the word problem. Okay. X dollars, and they gave you the X defined as raw materials and Y dollars defined as the labor costs. So this was all given in the problem. I just put down here 10,000 on raw materials is X, 1,000 on labor is equal to Y. But that was given in the problem. They gave you what the variables are. X dollars on raw material, Y dollar. No, that was given in the problem, Latoya.
Oh, because I was really like, it was like, where come from? It don't just
Yeah,
appear
yeah,
begin.
I know it was given in
thought
the
it was
problem.
crazy.
This is, yeah, this is the way it was given in the problem, just like you see it here. It's just that I put 10,000 on raw materials is X, 1,000 on labor equal Y. X dollars is raw material cost, Y dollars is labor cost. So when you're doing the function of raw materials and labor, and they gave you this formula. So you plug in X, 10,000, Y, 1,000, and then do the math. That answer your question, Latoya?
Y is gonna be 10,000 plus X multiplier.
No,
XY.
Y is 1,000.
Yeah, and X is
X.
10,000. So you
That's
multiply X and Y.
40 times X would be 40
Yeah, I know
times.
that part of the X
Oh,
and
but
Y.
this one is XY. That would be a 10,000 times 1,000. That's right.
That's what I wanted to find out.
That's right. And then divide that result by 100.
Oh, this is a divide. It didn't even look like a division.
Yeah. Well, we have
Oh.
the slash for the divide sign.
So everywhere you see X, you put 10,000.
That's right.
And when you see Y, you put 1,000.
That's right. So this is 10,000 times
So does
1,000.
3,600 go up to?
Well, the 36,000 is part of the formula. See?
Okay.
See, the production cost is described by the function F of X, Y, F, X, Y, F of raw materials and labor is equal to this formula. See, that was given in the problem. So the 36,000 is a constant plus 40 times the raw material cost plus 30 times the labor cost plus the product of raw materials times labor divided by 100. Got it?
Yeah.
Okay, so it's a matter of plugging in, substitute the values of X and Y in this formula. And that's exactly what we did. Okay. And there's the XY, 10,000 times 1,000, that's X times Y divided by 100. So we did that, the 10,000 times 1,000, and then divided it by 100, and that gave us the 100,000. So what we have left is 36,000, 40 times 10,000, 400,000, 30 times 1,000, 30,000. And then we took the 10,000 times 1,000 divided by 100. That gave us 100,000. Then we just add up everything and we got the total production cost as 566,000. That answer your question, Latoya?
Yeah.
Okay. All right. Now, okay. Now let's do number 2. Okay. Latoya, read number 2.
The rate of a talk time of two mobile networks A and B charges is 34 plus 0.05 minute and 40 plus 0.04 minute respectively.
Okay, that's 0.05 per minute. When you see that slash there, and 0.04 per minute. So you're gonna represent first the problem in function notation. Now you got two functions here. You got one for network A and one for network B. Okay, so Latoya, how would we represent, say, network A?
34.
Okay, 34 what?
Network A equal 34 plus 0.05.
Okay, now if we let X be the number of minutes, then what would that look like?
It said let X equal 34 plus 0.05. Something like that.
Per minute, so that would be X.
Per minute.
So then that would be multiplied by that minutes, which is X, right?
Yeah, I can't see where you're writing it.
Okay, let's see here. All right, let's just do this. Okay. Put this all on one screen. Okay. Okay. Write this up. Okay. So network A, the function of X, the number of minutes, you said the 0.05, that's per minute. So that would be time the number of minutes plus 34. So for network B, and that's what? $40 plus, that's a constant, plus 4 cents per minute. So that's going to be 4 cents per minute. So 4 cents times X plus 40. All right. So those are the functions for the two networks. Now, we want to determine if which network is more affordable. And if X, the average number of minutes used is 1160, how would we find what we pay for each network if for 1160 minutes? What would we do, Latoya?
Gotta multiply out and then divide.
What would you multiply?
Hmm.
What is X? What's the number of minutes?
0.05.
No, that's the cost per 1 minute. The number of minutes is X. So if you use 1160, you want to put 1160 minutes for the X.
It's gonna
Okay.
be 0.05 times 1160.
That's right. And you're going to do that for both of these. So do that and determine which one costs less. Put the 1160 for X in both of those functions. Add the 34 to network A, add the 40 to network B, and tell me which one costs less.
11. Oops.
So the 1160, the first one, you'd have 0.05 times 1160 plus 34. The second one is going to be 0.04 times 1160 plus 40. So do that and tell me what you get and which one costs less. The one that costs less is going to be the one that's more affordable. Okay,
0.05.
so let's just take this one for A. All right.
The first one is 92.
Okay, let's see. So you put the 1160 here, right?
Mm-hmm.
Times 1160. Okay. So you got, so this is F of, that's right. This will be 1160, because that's the number of minutes, right? Okay, so what did you get for this one, Latoya?
92.
Okay.
1160.
Okay, so let's see. When you multiplied the 0.05 times 1160, what did you get?
Plus 400.
That was what, 58?
Yeah.
Okay, 58 plus 32, and you got 92. What do you get for the network B?
I'm gonna get 84. Sorry, 86.4.
Okay, and then let's take the other one. Okay, here we go. Let's copy this one over. So that would be what, 0.04. That's for the second network, 0.04 times 1160 plus 40. Okay, and 0.04 times 1160. Let's see, you got what? 46.4.
Yeah.
Okay. Okay, so let's just copy this. Okay, so this was what I got. Let's see. 46.4. So 46.4. And then we added 40 to that.
So it's 86.4.
So which one is more affordable?
B.
That's right, because it's less. Okay, so this was network A. And this was network B. So the one that's more affordable would be the one that costs less. So B is less than A. So network A, we can conclude network B is more affordable because it costs us less than network A. Now, When is the monthly bill of the two networks equal? How could we find that?
You gotta add them.
No, you want to set them equal to each other.
You multiply them.
No, you want to set each function, set network function A equal to network function B. So what that means is you're going to take this 0.05x plus 34. Okay. And you want to put that equal to the 0.04. Okay. Okay. So we doing the part 3 now. Okay. So you set them equal. Now solve this for x. How would you solve this for x, Latoya? How would you solve this equation for x?
A minus 34 on both sides.
Yes, yeah, okay. So subtract the 34 from both sides. Okay, so let's just do that. Minus 34 and minus 34 on the right. What do I have left on the left side, Latoya?
0.05x.
That's right, 0.05x. And okay. And what do I have on the right side?
0.04x.
0.04x. What's 40 minus 34?
6.
Okay, plus 6. Then what do I do next? I need to get these x's together, right?
Yeah.
So what do I do to get my variables together here?
Add them.
Then if you add, what are you gonna add? Remember, I'm trying to get the x's on the same side.
Divide.
No, the 0.04x is being added on the right, so I have to subtract it, right? Subtract 0.04x from both sides. You do the opposite operation. See, it's being added to the 6, so I want to subtract it. So I get my 0.04x on the left, and then with a minus, I eliminate it on the right. So let's do that. Okay, so subtract the minus 0.04x and subtract it also on the right, minus 0.04x. Now, Latoya, what do I have on the left side?
0.01.
That's right, 0.01x. And what do I have on the right side?
Plus 6.
That's 6, right? Now, we can make this simpler by shifting the decimal point 2 places. 0.01x is the same as 1x. Move it. I'll just put the 1 here. Equal 600, right? Yeah, move the decimal point 2 places on both sides. I can get rid of the decimal. Move it here, that becomes 1. The decimal point here, move it 2 places, that becomes 600. So X equal 600. Right? So when is the monthly bill equal? X is the number of minutes. So the bills are equal bills when 600 minutes are used. Okay, so the bills are equal when 600 minutes are used. Okay, both network A and B bills are equal when they use 600 minutes. Now you can check it. You can go back up here and put the 600 in for the X and 600 here for the X. Okay, and you'll get the same thing. Okay, you put the $sign here. Yeah, you plug in the 600 here, multiply by 0.05, add the 34, plug in the 600 here, multiply by 0.4 and add 40. Tell me what you get, Latoya, when you do that.
So I'm gonna do 0.05
times 600.
times 600.
Right. And
Sure.
you're going to do the same for the network B. Okay, so let me just put this here. This is the way you can check that your answer is right. Okay, take the 0.05, this one, and for the X, put 600. We said the bills are equal at 600 minutes, and do the same for this one, 0.04X. And put in the 600. What do you get, Latoya? Put 600 here.
I didn't get it.
You don't get the same?
How much I'm supposed to get? 1100?
No, you supposed these supposed to come out equal. They're not gonna come out 1100. Because we said how many minutes do they use when the bills are equal? That means the cost they pay must be equal, right? So if that's the case, for 600 minutes, we should get the same cost. So what's 600 times 0.05?
I'm sorry, Ms. Barbara, where are we getting 600 from?
Oh, we got 600 over here, Chastity. I said, if we set these two network functions equal, we can solve for how many minutes are used when the bills are equal. So we set the network A equal to network B and solve for right up here, the function for A network and the function for B network, we set equal. Then we can solve for X, and we got X at 600. So when 600 minutes are used, the bill should be equal. And I said to check it, put that 600 minutes in for X and put it for each function, and we should get the same amount. We said they're equal. And I asked Latoya to solve that. What's 0.05 times 600? .05 times 600, Latoya. What's that equal to? 30, right?
I did it, but I thought it was wrong.
So what did you get? You got 64, right?
Yeah, I thought it was wrong.
Okay.
So,
And what's 0.04 times 600, Latoya?
I don't know.
24.
God.
And that's plus 40. And that's equal to 64. So we know our answer is right because the bill is the same. Because that was one thing we were supposed to find. What, well, the number of minutes we use when the bills, when is the monthly bill of the two networks equal? They are equal when they both use 600 minutes, right? But to check it, we put the 600 minutes in for the X, multiplied. Network A is 34, network B is 40, and we get 64.
Robert, I don't understand this one at all.
You don't understand how we got the 600?
No, you got the 600, but I'm like lost with these word problems still.
Okay, but I'm going back to my function. The network A function is 0.05x plus 34.
Yeah, but I didn't know function have word problems. I was
Oh,
like,
yes, functions do have word. Functions are something that's used in day-to-day
I was like,
life,
oh,
really.
happy. I don't like word problems. It's too much headache. I try to do it. I'm still not really understanding it too much.
Okay, so this is, all right, let's go back.
Two-part stuff.
Well,
Not even part. It's like 2 parts or 3.
yeah, well, here you're given two networks. First, you had to write it in function notation. The function notation is that constant plus the variable. The variable is 5 cents a minute for network A and 4 cents a minute for network B. The constant, that's a fixed charge of 40 for network B and 34 for network A. So to write it as a function, this is really still our what? MX plus B. That's like Y equal MX plus B. 5 cents is the rate of change. That's how much per minute. 4 cents is the rate of change, which is 4 cents a minute for network B. The fixed amount, 34 for A and 40 for B. So this is our old familiar formula, Y equal MX plus B. That's what our function is. So we know this is a linear equation. If we plot it, we'll get a straight line. Okay. So this is going back to something we've been doing, except we're calling it function. Remember I said, I told you the f of x is your output. That's like our y. Y equal m. M is the 0.05. X plus b, the 34, the constant. Same for this one. Y equal mx plus b. Got it?
Yeah.
Now, to determine if it's affordable when you use 1160 minutes, then you plug your 1160 in for the X. Find your total charge for A and your total charge for B. The lowest price is going to be the one that's affordable. And that you found as 86.4. Third part, when they're equal, set the functions equal, solve for the X, that's the number of minutes. So at 600 minutes, they're equal, right?
Yeah.
Now, what does that 600 minutes cost? It's going to go back to your function. It's going to be the 0.05 times 600 plus 34 for A, and it's going to be 600 times 0.04 plus 40 for B. See, these are all related, right? They're all related. Notice everything is going back to the original function. We set them up here. We set them equal to find the number of minutes when they are the same. And then we went back to the same equation, same function, put in what that minutes were, added 34, put in the minutes here, add to 40, and we got the amount of money paid when they're equal, and that came out the same. So everything is going back to that original set of functions. Questions?
I gotta read it over, Miss.
Yeah,
Barbara.
well, I'll be sending this all to you so you can read it over again. But remember, everything is going back to these original functions. That's why they ask you to put the function first, because the questions they ask you afterwards is using these same functions. Where we put X for the minutes, right? And they gave you an X value, substitute in for the variable, 1160 for the minutes, and solve for the function, the cost. Back to our Y equal MX plus B, where 34 is a constant, 40 is a constant. Variable is the X, all right? That 0.05 is really the slope. That's like our M. Slope is a rate of change, 0.05 per minute, 0.04 per minute, okay?
Okay.
All right, now I think we'll stop here. And
Got the time. Work change now. I ain't get to do nothing no more.
what?
I said work change now.
Yeah,
The work is, that's why you see I coming on so later and later now, because
Oh, your work is changing, okay. Okay, so homework, I'll give you number 3 and number 4. This one is actually of, okay, you've got a function and you define X.
it's not
Now,
a word.
well, it's not a, this is not a word problem.
My homework.
This one is, you're given the output 11 and you define X. So you're gonna put 11 equal 3X plus 2. And the same for this one. You're given the output 25, so you're gonna put 25 equal minus 2X minus 5. Find X, okay? So those two, and then
Oh,
I'm giving you some tables and you just to tell me if they are linear, quadratic, or exponential.
oh Lord.
So take your differences, see if they're ratios. If the ratios are the same, that's exponential. If your differences are the same, then it's linear. If the second difference are the same, then it's quadratic. So that would be your homework. I won't give you these. So your homework will be, let me go back up here. Your homework will be 3 and 4. Find X, given the function value, find the input. 25 equal minus 2X minus 5, solve for X. So this one, I'm gonna start you off. That would be 11 equal 3X plus 2. Now you can solve that for X, right? And then the next one, of course, 25 equal minus 2X minus 5. So, and this one, I'll put here, this will be 25 equal minus 2X minus 5. So you're going to solve this equation for X, solve this equation for X. And then the next 4 is just to find the whether it's linear, quadratic, or exponential. So your homework really starts here. I have it here, but it starts here. Homework. That's your homework. And Latoya and Chastity, if you want to text me answers before, I can check them. So it's up to you. If you want to text me homework, you know, just whatever your answer is here, whatever is X, just tell me the X value and do the same for the number 4. What's the X value? And then for the other ones, you could just tell me 5 is exponential, 7 is quadratic, whatever it is, and then I'll let you know if it's correct. All right.
Oh, no, I would try.
Okay. So solve this equation for X. So Chastity, to solve this for X, you're going to subtract 2 from both sides. That's going to be your first step, right? Right
Okay.
here. And then once you do that, then you're going to divide the result by 3. And that's your answer. Latoya, got it? Okay, so we're going to stop here. Right,
You're gonna send me this?
yes, you're getting all of this. I'll be emailing this to you. Okay. And then
Oh,
since
thanks.
since we